Hi everyone, welcome to this episode of Kuiper Labs. In today's episode we're going to talk about electromagnets. So we're going to start in this video to recapping what we understand about magnetic forces. We're going to look at the difference between permanent and temporary magnets. We're going to look at what is an electromagnet, how they work, how we can make them stronger, and we're going to compare them with permanent magnets in terms of their properties and their characteristics, and then look at what electromagnets are used for in everyday life. So firstly, recapping what we understand about magnetic forces. We recognize and remember that magnetism or magnetic forces are non-contact forces that can act at a distance, that we can experience a magnetic field or the effects of a magnet without actually touching it. We do have this area around a magnet where it has an effect, which is what we call its field, and we can represent it with lines that go from the North Pole to the South Pole, as you can see in this image. Okay, we call those field lines. We can see that then magnets can interact with each other and with other magnetic materials, that depending on which ends of those magnets are pointing together, that we see that opposite poles, north and south, will attract as the field lines line up. Whereas if we put north and north or south and south poles together, that we see they repel or push away from each other. And we can visualize that seeing the iron filings in the photos on the right hand side of the screen, seeing the difference in those fields. Okay, so it acts at a distance, that we have a magnetic field around the magnet where it acts, we represent with lines, and then depending on which ends of the magnets are pointing towards one another, we see particular behavior. But all of these are describing the behavior of magnets, which we call permanent magnets. They're all like these bar magnets that you might have experienced in dealing with in everyday life. So we call them permanent magnets. The name, as it suggests, is that the magnetic force is always on. You don't switch it on or switch it off. It's always magnetic. Whereas other substances and objects may be temporary magnets. Now, we might give them this label for one of two reasons. The first one could be that the magnetic force that they experience only lasts for a short time, or it can be because that it can be switched on or off. So in this image here, that the paperclip becomes a temporary magnet because of the effect of the permanent magnet. It's almost like some of it rubs off on the paperclip, giving it magnetic properties, but they wear out quite quickly. That it stops behaving like a magnet, that force gets weaker and weaker over time, and until then it behaves just like an ordinary object. Whereas the permanent magnet on the left is always going to behave that way, unless we destroy it or we cut it up, and even then we're only really changing where those poles might be. It is always magnetic. And so the reason we want to talk about this is that electromagnets are another example of a temporary magnet. But what is an electromagnet? Okay, so that we can see that it's got some different components here. This is a bit of a diagram of it. But an electromagnet is essentially made up of three parts: an iron core, some turns of wire that wrap around that iron core, and a power supply that connects to both ends of that wire. So we can see in this image here we've got an iron core, so it might just be a little iron rod, it could be a nail or a screw or something else of that nature. We've got turns of wire that wrap around that iron core in a cylindrical kind of pattern, like a spiral, and then it's also connected to some form of power supply. Now, it might be a battery, it might be some sort of other transformer or something else that supplies electrical energy. But the reason that we do this is that we're creating a magnet or creating a magnetic field that can be switched on and off. And now that has a great deal of use for us in everyday life, to be able to create a magnetic field on command. There's lots of situations we're going to look at a bit later where that's very useful. Okay, we can see here is a photo of a homemade version of an electromagnet, so they don't always have to be massively fancy bits of equipment, that we can do this in the science lab, or you can even do it at home. We still have an iron core, which in this case is a nail. We've got some copper wire that wraps around it, and then it's connected to a power supply. Now, the fact that it's copper wire, and copper is not magnetic in and of itself, doesn't matter, because the copper itself is just to allow the flow of charge through from that power supply through the wire and then back to the battery again, and then it influences a magnetic field in the iron, which is the thing that then ends up having magnetic poles. So how does an electromagnet work? I kind of just alluded to it a little bit just now, but this idea that we have this wire connected up to a power supply, the current from that power supply, that is the charge flowing through that wire, because of the push of that power supply, as it goes through that wire, it generates a magnetic field in the piece of iron. Now, and then this iron core in the middle, whatever iron it is, now has north and south poles based on the ends of where those wire is connected to the power supply. Now, I'm not going to go into much more detail as to how does this current generate a magnetic field, because it's really quite complex, and that's probably beyond what you need to be understanding in this video at the moment, and it's certainly something worth looking into if you want to know more about it. But it is definitely a more complex interaction between electricity and a magnetic field, and even I've struggled to understand it really deeply. Okay, but so this is the principle behind how an electromagnet works. So then, knowing that electromagnets are temporary magnets, we can turn the magnetic field on and off by connecting all these components in this way. So then it begs the question of saying, well, how can we make it stronger? How can we adjust the electromagnet to suit our purposes or our needs? And there's two main ways in which we can do this, in terms of simple ways to do it. The first one is that we can add more turns of wire to our, in terms of what's wrapping around our iron core. You can see this in this image here, where we've got 4 identical kind of iron bolts, I suppose they look like, rather than nails or screws, and where we've just increased the number of turns of wire that go around those iron cores, and it creates a stronger magnetic field. What we can also do is we can increase the amount of charge that's flowing through that wire. So typically the way we would do that is to increase the voltage of the power supply that's pushing that charge through that wire. So if it's a power pack, that you might turn up the dial, or you can add more batteries, or you can, there's a range of different ways you might increase that current. But the more charge that's flowing through that wire, the stronger the magnetic field it generates in the iron core. And so then that is a lot of what makes electromagnets so useful in everyday life. But if we compare them with permanent magnets, we can see that permanent magnets, when the magnetic field's always on, whereas the temporary one, electromagnets, we can switch it on and off with the power supply. Permanent magnets, like bar magnets, are made of hard magnetic materials, whereas electromagnets are made of soft magnetic materials. You don't need electricity to make a permanent magnet work, but you do for an electromagnet. That's the point. With a permanent magnet, you can't vary the strength of the magnetic field, but with an electromagnet, we can do that very intentionally according to our needs. And with a permanent magnet, we've always got a set north and south pole, whereas for electromagnets, we can reverse the poles depending on which way we connect the wire. And so that gives us an extra dimension to its usefulness that comes into play. Okay, and so let's think of some of the common applications or the ways in which electromagnets are used in everyday life. One that you're experiencing right now in listening to my voice is that through the use of speakers. We have an electromagnet inside a speaker. Now, whether it's a bigger one for hi-fi or inside your headphones or whatnot, or inside your computer, it still works on the same principle. It has an electromagnet inside the speaker that then, as that's switched on and off, and it's by connecting up to the main electricity, that it switches directions multiple times every second. And what that does is it causes this kind of cone here to vibrate at a set frequency, and it pushes on the air, which then pushes out what we experience as sound waves. It's not just about speakers though. We also use electromagnets in medical devices like an MRI scanner, which you can see a photo and a little sketch of here, where we're using a magnetic field to actually study the inside of a patient. Along these same sort of lines, we can use magnetic fields to actually study samples in things like forensic science, where we can look at studying more about the chemicals inside a sample that we're looking at. But also in a different context altogether, we can use it in metal recycling, where we're actually picking up iron-based substances like scrap metal for car destruction, or in metal recycling at the tip or the dump, to be able to actually pull out iron-based objects because they respond to the magnetic field. We can take them and we can move them away for recycling. Okay, so we recapped what we understand about magnetic forces. We looked at the difference between permanent and temporary magnets and understanding the differences there. We looked at the basic structure of an electromagnet and how it works in generating a magnetic field. We looked at some of the things we could do to make that magnetic field stronger by increasing the charge and increasing the number of turns in the wire. We looked at some of the properties of electromagnets relative to permanent magnets like bar magnets, and also looked at some of the common uses for electromagnets. Alright, thanks very much for watching. Don't forget to like and subscribe. Bye for now.